Okay, super. So, hey, welcome everybody. Hopefully this will be informative and interactive. If you have questions, please chat. My goal is to talk today about not just cloud security, but specifically zero trust use cases and why that's important, and some things that you can do practically to advance your security posture. So, but first, let me introduce AccuKnox, where I'm active as the Chief Product Officer, and we're happy to be here today. A little bit about us. AccuKnox was founded a little over 2.5 years ago in partnership with SRI, the Stanford Research Institute. You might know them as the inventors of the mouse, the modem, and even Siri. So a lot of deep technology comes out of that think tank for R&D, and we've partnered with them to bring some of that to market here for cybersecurity. Also venture backed by some of the top names in cybersecurity investing. Beyond the investors, we've got some incredible advisors, folks like Michael Collins, Andrew Martin, folks that have really been pivotal in charting the course of security in the cloud native environment. So we're just thrilled to have them involved in supporting us through this journey. Okay, so what's happening in the world? This is over the last couple years. The number of attacks and the variety of attacks on cloud native infrastructure and Kubernetes in particular has started to rise. And there's everything from cryptojacking to infiltrating infrastructure, worms, bots that are written directly for Kubernetes, leveraging WordPress pods. There's a lot of activity here, and like we say, the criminals will go where the money is, and today, data is the new money, right? That's how they're able to leverage their attacks against identity and financial attacks. So this is the new threat landscape going forward for the world. And so in that context, simple perimeter defenses just aren't going to cut it anymore. The things that we used to use, network firewalls, antivirus, they're not going to be appropriate or capable for the modern infrastructure that we're dealing with. So we're also living in a different world, right? So where applications that are managing our data are created not just by a team of in-house developers, but the open source and third-party libraries. The supply chain for software creation has greatly exploded. And so that's a legitimate threat, not just something to help developers write code faster, but it needs to be managed and contained in the right way. So whether it's open source supply chain or Kubernetes specific threats, the nation states are going to go after those things. But we're also seeing weaknesses in the trusted cloud infrastructure. Right, so we've seen Kubeflow, ChaosDB, Log4j. A lot of these other tools that we've come to rely on have had their challenges and vulnerabilities. And so it's very difficult, if not impossible, to lock down all these vulnerabilities. That assumes you even know where they are, right? Let alone 0 days that come out. So let's talk about securing the cloud. So what is this cloud that we're talking about securing? People often talk about it like it's a discrete object, something that can be secured. But in reality, the cloud looks more like this, right? So it's diffuse, it's spread out, it's amongst our buildings, right? So no one has a pure cloud operation. Well, maybe a couple organizations, but by and large, the majority of companies that have been around for a couple of years have on-prem services, hardware, software. They've got remote and on-prem employees. They've got local devices. They have existing infrastructure that they have to secure. So it's not just the stuff in the cloud, and that stuff more often than not talks to each other. And they have existing tools, right? No one's starting from scratch. So, you likely have, software or tools for host security, some kind of static code. Network security. So there's a lot of different tools that are already existing in your infrastructure. And you may have the open source version, you may have the commercial version. So what are you going to do with that, right? As a security professional, it's quite impractical to say, hey, we're going to have everything covered by one tool, right? We're going to buy the biggest public traded company's product, and they're going to solve everything for us. The world is more complicated, especially when you look at some of the cloud providers have some of their own tools that are more appropriate than a third-party tool. And so, our goal is to really tie that together for organizations, to make sure that they have a single pane of glass that orchestrates the collection and management and making sense of all that data. Whether that means a commitment to supporting open source software, whether that's our own or other open source projects that are that support the cloud native security objectives, whether it's detecting misconfigurations, image scanning, cloud native identity or Kubernetes entitlement management, and runtime security, of course, which is one of our key focuses. So the goal here is that to tie everything together and make it usable, whether it's in the cloud, on-prem, behind a specific firewall. You need that flexibility to get at that scan data and make sense of it, and that's what we've built our product around. So let's talk about specific types of applications and some threats. I mentioned Kubernetes before, and I think that's a great place to look. We could also talk about virtual machines with VMware on-prem or EC2 instances. But let's talk about Kubernetes, because 96% of organizations are either using or evaluating it for their cloud workloads. It is the future, and it's a very large and robust community. There's estimated 5 million. Hey, someone's audio is still bleeding through this. Varsha, could you lock that down, please?
I think Kolanu and Ashwin, maybe the moderator, please, can you mute Kolanu and Ashwin, please?
Yeah, thanks, guys. So Kubernetes is not just running in the cloud, right? It can run on-prem in your private environment, and even at the edge. The edge can be mobile devices. They could be vehicles. They could be manufacturing facilities. So Kubernetes is everywhere. So it's very important to consider that as a development environment, and it's certainly on the rise. Now, that being said, over 2/3 of organizations are reportedly delaying or pausing their projects due to security concerns. Study by Red Hat. So why is that? Well, if you think about it, Kubernetes was really built to run and orchestrate workloads. So it's open by design. Unfortunately, security is an afterthought, and it's being added on as another set of projects that are being individually rolled out into the architecture. So not baked in by default. So what does that mean? Open by default means that processes can run unrestricted within the containers. There's no way to lock that down. Permissions are often excessive. And and the inherent complexity of Kubernetes. And if you've tried to use it to roll out applications, you can get a sample app up and running pretty quick, but in the real world, where you have to deal with persistent data volumes and resource limitations and allocations, and then horizontal scaling, there's a lot of complexity here to rolling out applications and securing them. So let's think of some use cases. So what could you do to help add security in here? There's a lot of talk about zero trust, and to be clear, when I talk about zero trust, I'm not talking about identity or EDR that might be on your laptop. We're talking about in the cloud workloads. So secrets management, for example, securing passwords, hardening your applications, making sure that they're conforming to CIS benchmarks, doing networks microsegmentation, preventing the blast radius, right? Say there's an application that gets infected. How do you restrict that, right? That's the key use case for microsegmentation, and that's one of the fundamental parts of zero trust. File integrity management, making sure that the attackers can't get to the crown jewels. And of course, in the cloud, everything's changing very quickly. That's why we put it there. So how do you monitor for misconfigurations? How do you detect when something has changed beyond a tolerance level and has come out of compliance? So let's talk about credentials. Credentials, they're a key risk. Almost 40% of attacks involve credentials in the cloud. Out of the cloud, in other non-cloud environments, the number's actually higher than that. I've seen estimates between 60 and 75%. So these can be application secrets, passwords, different tokens used by service accounts or applications. So this is why a lot of organizations have a secrets management project. So they can take those tokens, take them out of GitHub source code repos, where they're often hard-coded into applications, and put them in a centralized location and have some access management for who gets to borrow those passwords for a specific amount of time. So HashiCorp Vault's one example. They have an open source tool version which is free to use, and that helped them get a lot of traction. Other providers have tools as well, other IDPs. So depending what you're doing, this is probably going to be one of your first projects in Kubernetes is to manage your secrets. So in this case, secrets are stored in a directory, right? They have to go somewhere. So they go on disk in a directory, usually /vault, unless you rename it. So hackers know this, right? Because it's open source and all this is published, right? And they're going to want to go after the crown jewels, and that's the credentials. And now if they're able to get in there, they could potentially delete, modify, or even encrypt those secrets and passwords, right? Making them unavailable to applications, which could bring your operations down. Or they could even encrypt them and hold them for ransom and ask for some Bitcoin to get those back, right? So it's not, ransomware isn't just for laptops. It's in the cloud now too. So what can we do? How do we protect our secrets? So luckily, there's a pretty cool tool out there called KubeArmor, which was created by AccuKnox and donated to the CNCF, where it's now a sandbox project that's got over 500,000 downloads. We just had the community meeting at KubeCon last month in Amsterdam, and it was standing room only. There was over 40-something people there who were interested in using it in their projects, which is just tremendous tremendous level of enthusiasm for it. So what is it? This KubeArmor, which by the way isn't just for Kubernetes, but it will essentially allow you to implement a zero trust policy that's as simple as this. Only allow the application bin vault to access the directory vault and deny everything else. So that is the definition of a zero trust policy, right? So specify what you allow and deny everything else. Or some people say, deny everything and then add in what you're going to allow. The net result is the same. So great. So what is this KubeArmor? Now that you have a sense of what it can do for file access, think of it as KubeArmor is really an application and system hardening tool that allows you to implement your zero trust, otherwise known as least permissive security. It's not just for files, but it's also for process execution and network connectivity. And I'll talk about how you could use it for network segmentation as well. And what it does is it creates an easy to read universal policy language, which is, YAML. That's the language of Kubernetes. So it creates this universal language that allows you to enforce user-specified policies or policies you get from somewhere else, where you can write that policy once and run it anywhere. Now, some of you are thinking, hey, this kind of sounds like a Linux security module. Well, you're right, because what we actually do is we use the LSMs. You might be familiar with AppArmor, SC Linux, that have been on Ubuntu and Red Hat systems for decades, right? Those have been approved on the Department of Defense list of projects to secure workloads for a very long time, and they're embedded in the Linux kernel. So we're essentially taking those tools and writing the language for you, right? Because each language is different, and if you've got a workload that's running locally on Red Hat, and then you want to put it in the cloud, but it's going to run on Alpine or Ubuntu, which is quite possible, or maybe a ChainGuard distro, we can enforce the appropriate LSM code without you having to know it. And if anyone has tried to write SE Linux permissions and enjoyed it, you'd be in a minority of people. It's very difficult and to get right and time consuming. So we automate that for you. And because in the kernel, it's very high level language and very high performance. So where do you start, right? Well, luckily you don't start with a blank slate. There's an open source template library that has best practices for NIST, CIS, PCI, and even MITRE frameworks that you can start with. You can copy them, modify them. You can create your own, update them, share them with the industry. So what does that look like? Well, here's an example YAML here. Looks like a lot of Kubernetes manifests, but you can see we're specifying the action to take, what we're going to block for a particular, this one happens to be for, MySQL to prevent remote file copies off of a MySQL database container. So we're preventing rsync and SCP from running. We have these tags down below so that you can see that this is specified as MITRE attack framework tactics. So that comes in helpful later if you're looking at the logs or want to make sure that you apply MITRE to all of your workloads. We talked about network segmentation a little bit, and the goal I mentioned was to limit the blast radius, or prevent lateral movement. If an attacker is able to leverage a misconfiguration or a vulnerability and get onto a container, how would you prevent them from moving to other containers, which by default they have access to in Kubernetes? So we're going to apply a specific security policy, which says only allow ingress from an app whose pod selector name is WordPress on port 3306. So by default, everything else is denied. So if there's another client that's trying to connect to that same MySQL pod in the background, it'll be denied because it doesn't meet these criteria. And again, this YAML file will be digested by KubeArmor and pushed out to the appropriate workloads and implemented as a protection inline in the kernel. Okay. All right. Quick quiz here. Who knows what agile principle number 3 is? I know we've muted everybody, but just think out loud to yourself. What is agile principle number 3? Because it's release time, and principle 3 is release often, release early, from the Agile Manifesto, dating back a little while. So the example is, devs say, hey, I'm going to upgrade my app to the latest library, because that's what devs do. Security is going to then say, okay, if I even know that happened, is it safe? Is it secure? Is it compliant? What's changed there from the last version? How do you know that? And then ops is going to be concerned about it. Is it still going to run? Did that library, introduce another resource requirement? Or did it reduce resource requirements? Can I now set my resource limits lower? What are the network changes? So this brings up a very important point about visibility into the applications, which are fundamental to managing them as well as securing them. So we have a tool as part of our enterprise suite called application behavior analysis. And there's some level in the open source one as well. But essentially what this does is it lets you see the network file and processes as they're actually happening in the application across all of your pods in your infrastructure. So you can see here, this one happens to have the vault container in the middle, and it's showing who's accessing it, who's coming in on ingress to get their secrets, and what traffic's going out. So you can use this to say, hey, is this the behavior I expect and approve in my cloud environment? Is there a misconfiguration that's allowing an intrusion, or is an admin, someone in the team, accessing something that they shouldn't be, right? Do they have permissions that they shouldn't? Is there a supply chain issue? So visibility is very important. And I mentioned changes. Changes to your infrastructure are going to happen. They're going to happen all the time. And it's important from a governance and compliance perspective that we're able to show when a approved configuration changes over time. And we can do that in AccuKnox with a feature we call baseline, so that as we're taking in the different tool data, whether it's a SonarQube or source code scanner, or a CloudSploit or Trivy or any of these other types of cloud scanners, we can measure it and set expected results. So we could expect this result and use that to compare to future results, so that we reduce the noise that's coming, right? Because these scanners are they're going to give you a lot of data. And now the hard work is figuring out what's important, what's a real incident. And so we can use this baseline feature to trim that down and focus on the things that truly are different. So not only do we take this information in, but we make sure that we have integrations to share the data out with other organizational tools that you may have. So think of your SIMs like Splunk, CloudWatch, Elastic notification tools like Slack or PagerDuty, ticketing tools like Jira, ServiceNow, ConnectWise, things like that. And then obviously we're connecting to your cloud source code repos and image repos as well, like Docker and Nexus. So, in the spirit of, connectivity, it's, again, I want to kind of remind you that you're not just trying to protect the cloud, you're trying to protect everything that is also connected to the cloud, regardless of where it lives in the whether it's on Kubernetes or bare metal or on some edge device in a vehicle, traveling across the country on the highway. So, I mentioned that we're based on open source, so I'd encourage you guys to check out KubeArmor.io. It's a great tool that's got a really unique approach. Only one in the industry that's leveraging LSMs in this way. And you can check out more about the AccuKnox enterprise application, AccuKnox.com. So that was pretty much what I had hoped to cover as an initial presentation. Varsha, did we want to open up for some Q&A or?
Yeah, sure. Yes, so that was a great, insightful presentation, Rick. If any one of you have concerns or questions regarding the presentation thus far, please, you are allowed to unmute now, or you can ask questions.
Hey, hi, Rick. This is Satish. It was a really great presentation from you. And few of the topics which I was also working on. So, we just started a little while ago. But I have a couple of questions or showstoppers that what we are facing and how your approach or AccuKnox approach would be much insightful for us. So the first thing is you were telling about something about the security layer, what we have on top of any public cloud or a private cloud. So how do you see the security concern when you have an hybrid cloud? Let's say your infrastructure on the back end is still residing on the on-prem and your application is residing in one of the cloud. So what sort of network layer security that you would prefer from the attacks?
Well, I may be biased, but I think there's good reason to look at application hardening and firewalling. Yeah, I don't know if that was your question, right? And the reason,
it was part of because application, again, let's say for example, we take Azure or AWS where one of our application is residing there. And let's say, for example, my application is hardened with respective to AWS security parameters, but whereas the databases or the infra or the external servers which is connecting to or is connecting to via a middleware or something else, right? So it again resides on the on-prem. So our major activity is something like between our on-prem servers or infra, we have a very good network layer. But when it is converted, when the data is being moved from your on-prem to cloud, when cloud applications is actually reading it, so how does that network layer, because ideally it has to go via internet or two different networks, right? AWS network or your company's network. So how the network layer will be so secured, and what are the major things that we need to think of? Because the code what we are writing on the on-prem servers are being deployed on the AWS servers. That's again just migrating the data here and there via Jenkins or something else. But when the applications are connected between two different layers, and it's really hard for us to do the compliance, right? To achieve the compliance actually.
From on-prem to the cloud.
Yeah, right? when actually it's an hybrid environment.
Yeah. That's I think that's, there's multiple layers in what you're asking, right?
Yeah, yeah.
The nice thing about, starting at the application or container layer is that security goes with the application. You can even store the policy in a YAML with the source code for that application. So I think that's, as we look at like the trend over time, what's happening is applications are being atomized, broken into smaller pieces, and distributed. So the security needs to be distributed with it, right? There's really no more centralized security, because you may find, as we did recently, hey, you're going to get a better deal on GCP, or Azure is going to make you a deal to run this application, or right, oh, maybe my developers say that they like the chat GPT, right, the open AI stack, which is in Azure better than Bard APIs. And so you're going to have to, as a cloud security team, you're going to have to support and secure all those. So
Yeah.
I think it's a combination. You'll have to leverage some of the cloud security providers, networking security tools, but within that, once you're in that fabric, wouldn't it be great to have a universal language to define what the application can and can't do, whether it's running in GCP or on-prem or AWS? So I think that's kind of the future.
Yeah, our major issue is, I'm just giving a scenario where what I'm working on currently and what is the pain point that I'm really having. We have a few applications on GCP, we have few on AWS, we have few on on-prem. So each cloud provider has different sort of compliance.
Just kidding.
Albert, can you mute here? Thanks.
Yeah, I did that.
Yeah, thanks. So while we are doing this layering, especially with the compliance, right? Each one of them has a different version of compliance. So we are really, it's very difficult for us to find a provider where we wanted to have a same benchmarking for all the applications along with our on-prem. So we are ending up like buying different products for each cloud provider, and we're spending a lot of money there. So what my concerning was, let's say you have an API that you are calling from GCP, and I have to implement something like API security on top of that application, and that is not 100% supported by GCP, from AWS. So, and something that we are doing on the on-prem, I know that firewall management around the network, that might work to an extent, but when the hacker is really coming into the systems, it's very difficult for us to secure, even though with the network segmentation. So what are like cloud providers' thought process, or like you guys who are actually giving solutions, what are your thought process in resolving such type of complex environment structures, especially with respect to compliance?
Yeah, this was probably a lot of
probably I have put so many questions in one single question.
Yeah. Maybe I feel like maybe it's a type of thing where we could pull out a whiteboard and have a longer conversation on it. I don't know if you wanted to maybe set up another. I'm not sure how I'd answer it here. Right now.
Yeah, sure. I will anyway connect with you.
Hey, Satish, my name is Nat Nataraj. I believe you're at Equinix, correct?
Yeah, true.
Okay,
yes.
Okay. And we can do an offline discussion. And these are all things which a number of our clients have wrestled with. And we got folks such as Rick who have been able to address them. But it might take a little bit more time than what we have on the
call. Because nobody is asking questions. So I thought, okay, I'll put my first. So that's fine. I am open to other questions. Yeah, thanks. I'll touch base with you, Nick. Thanks.
Yeah, thanks, Satish, for starting us off.
Hi, this is Yash. I have a small question. Basically, I work on the data side mostly, supporting like software applications and like any data related ad hoc requests. I have one question is like oftentimes in our team, in my experience, one thing that we get stuck is when an audit happens, they just ask like a simple question like, okay, who has access to what? And everybody's like panicked, and we don't have like a proper way of giving an answer, like an email or like a bullet statement or something. Like, is there anything that in your experience when a audit happened, what exactly the approach is to answer that question, like who has access to what? Is there any best practices that you guys have ever been recommended?
Actually, that's a frequent topic for me almost every day this week, because we're working on a feature that would answer exactly that question and give you a graph view of what different users have access to in both direct or in the other direction as well, like who can access or which resources X number of people have access to. So there's a couple open source things out there, which I can't recall the name of right now, but like each of them has like a little bit of, it depends on the tool set. Like there's one for Kubernetes called KubeBench, which we actually support as an open source tool in our product. So you could start with that if it's for Kubernetes, and then each of the the CSPs have their own tools as well, and we would integrate that data and try and give you an integrated view across the clouds. So I don't know if that answers your question.